today our learning objective is to apply congruence and triangles. We're going to cover a couple of vocab terms. The first one is congruent figures. Congruent figures are two geometric shapes or figures. They are congruent if they have exactly the same shape and they have to be exactly the same size. Okay, I'm going to use a template today. A template is just something that helps me draw, and I'm going to choose one of the shapes. So I'm going to choose this one here. And this shape here, I'm going to use a triangle and show you, and I'm going to turn it different ways to show you that, or to demonstrate that these are congruent figures. Okay, so here I know that I'm going to use different colors. This side right here is congruent to, is the same length as this side. This side right here is going to be the same length as this side right here. And this side right here is going to be the same length as this side. I can also show you that this angle here is congruent to this angle here, because I've used a template to draw it. This angle here is going to be congruent to this one, and the last one, this angle here, is congruent to this angle here. Okay. So the next one is talking about corresponding parts. Incongruent polygons, like we have right above, corresponding parts are the matching sides and angles. So when you have shapes like this, it's easier if you draw them the same direction. So you would rotate this one around so that you can have them all lined up. For this one, I'm going to go ahead and just use the traditional equilateral triangle because it'll make things a lot easier. Okay, so I have two triangles. I'm going to call this one the cat triangle, C-A-T, and I'm going to label this one the dog triangle, D-O-G. We know that C-A and O-D are matching sides, so we say that they are corresponding. C-A and D-O correspond. We say that A-T and O-G are corresponding. So I'll list those. A-T and O-G are corresponding. And then the last one, C-T and D-G. Those two sides are corresponding. They're not always, we don't just have corresponding sides, we also have corresponding angles. And normally we use 3 letters to name our angles, but for today, just to make things a little bit simpler, I'm only going to use the vertex. So here, angle C and angle D, these two are corresponding. I'm going to use a little marker here, a little color, to show you that those two are the same. I forgot to mark this one for you. Okay, and then we also know that angle A and angle O are corresponding, and then finally angle T and angle G are corresponding. And if you want to match your colors to your pictures, that would be helpful. So here, the purple side was the AT and the OG. So AT and OG, here's the purple one. And then the pink one is the CA and the DO. It's also going to be angle A. Well, I'm sorry, not angle A. I was going to use the color across from it, across from the angle. So over here, angle T and angle G. So those are the pink angles. And then the last one, the yellow angles, are this A and O, as well as the DG and the CT. The only one I didn't color in was the angle C and the D. So now you can match the color to the picture. Okay, congruent statement. When we have two congruent triangles like this, there are congruent statements that we can write. When you write a congruent statement for two polygons, always list the corresponding vertices in the same order. You can write congruent statements in more than one way. So let's write all the different ways that we can write the congruent statements for these two triangles. First of all, we know that triangle CAT is congruent to triangle DOG. The C matches with the D, the A matches with the O, and the T matches with the G. So we can rearrange these letters. I can call this one ATC, A in the middle, over to the right T, and then back around to C, would mean that I would have to go O in the middle, over to the right G, and back around to D. I have to keep them all in the same order. And then I could also start with the letter T. TCA is one way I could name it. So if I do TCA, I would do GDO. Okay, and we can keep rearranging the letters in all the different ways, but these are three of the main ways that you can write your congruent statements. Here's what it's going to look like in your book. Write two different congruent statements for the given triangles. Okay, so that's number one. Then list all of the corresponding angles, B. Then list all of the corresponding sides. Okay, so here, A, we're going to say triangle ABC is congruent to, watch, A is one arc, so it has to match F. So A, let me rewrite the A, matches with the F. B, that has two arcs, has to match this one over here with two arcs, so that's E. And C has three arcs, so we have to match it over here to D with three arcs. Okay, so that's one way. And I could just rearrange the letters another way, so I could call this CAB. CAB, so this one has to be DFE. And of course there's other ways that we can do it, but there's just two of them. Alright, B, we want to list all of the corresponding angles. Okay, so angle 1 and angle F, angle A, I said 1, oops, angle A and angle F, angle B and angle E, angle C and angle D. Okay, and again we normally use three letters, but for today's purposes I just wanted to show you how we match one arc to one arc, and two arcs to two arcs, and three arcs to three arcs. Okay, C, we have AB, side AB with one hash mark is going to match side EF with one hash mark. We've got AC with two hash marks corresponding to FD with two hash marks. And finally we have BC with three hash marks corresponding to ED with three hash marks. So that's how you do this one. Example 2. Here we have not triangles, but we have another geometric shape. It is a quadrilateral, and in our quadrilateral we are told that DEFG is going to be congruent to SPQR. So in this name we know that the D and the S correspond. So I'm going to mark D with one pink arc and the S over here with one pink arc. Those two correspond. Then the E matches the P. So E is over here, matching the P over here. And then F matches the Q. So F is over here, matching the Q. And then G matching R. So G over here matches R over here. Okay, so we want to find the value of X and find the value of Y. Alright, since we know that X is up here on the side and Y is in here, X and Y is in here inside the circle representing an angle, we want to find X first, so we want to look at the sides. Looking at the sides, I know that side QR, run out of room, I'm going to put it as close to the top as I can. QR is going to be congruent to, and QR corresponds, it's between the green and the blue. So I start with green and then go to blue, so here it has to be FG. FG. And you can get that from the name too. QR right here is going to correspond with FG. Well, when they're corresponding, they are congruent. So here, this is QR, we know is equal to FG. We can replace QR, the letters QR, with 2x minus 4, and we can substitute in 12 for FG. Now it becomes an algebra problem. We just add 4 to both sides. That will leave us with 2x on the left equaling 16 on the right. And now divide both sides by 2, and we get x equaling 8. Okay, there's half the problem. Now we want to look at the angles. We know that this green angle is going to match this green angle. So here I know that angle EFG, which is the green angle, is going to be congruent to PQR, which is the green angle. That tells us that the measure of EFG is equal to the measure of PQR. EFG is 68, so I'm going to substitute in 68 here. PQR is 6y plus x. We're going to use our x from our previous problem here and substitute it in. So that's going to be 68 equals 6y plus 8. And now it becomes an algebra problem. I subtract 8 from both sides. On the left-hand side I'll have 60. On the right-hand side I'll have 6y. And now just divide both sides by 10 and you get y equals 10. Okay, so there's my x and my y. Next, I have two triangles here. And it helps if you have color because you can show that these right here match. You can show that these right here match. And see how it's flipped over. And then you can show that these match. Okay, so here I know that this angle here is going to match this one over here. And then I know that this green one here is going to match this one. And I know that this one here is going to match this one over here. Okay, in example 3, we know that we've got all the side. When it says show that two triangles are congruent, they're asking us to prove that all sides are congruent. Let me fix that congruent symbol. Are congruent, and all angles are congruent. The easy part of this is that the sides are already shown to be congruent by these hash marks. I put these little arc marks in here to show you which angles were corresponding. These, we don't have proof yet that they are actually congruent. That's our job. That's what we have to do. But first of all, we can say that PS, the green side, is going to be congruent to RO because that was given to us. We are also able to say that TS is congruent to TO because that was given to us. The TS is the pink side and TO is the pink side. PT is congruent to RT because all of these, this was given. So our job is to actually go through and prove that these are, all these angles are congruent. Now, one thing I covered up when I colored in was this mark right here. This mark right here means that this side is parallel to this side. So we've got, if we extend these lines, we have two parallel lines. So our two parallel lines, when we cut them by a transversal, we know that alternate interior angles are equal. We can also use this one as our transversal, and we still know that alternate interior angles are equal. Okay, so that's where we're headed with this. We know that angle PST is going to be congruent to angle ROT. So PST, this one here, is going to be congruent to that's a Q, sorry, RQT. No, it's not, sorry. Looks like a Q there, but it's an O here. So let me change that back to O. ROT, and that's because alternate interior angles are congruent. Okay, so we've got one set of angles congruent. Now we need to get another one. The next one is angle SPT. SPT, the pink angle, is congruent to ORT, this pink angle over here. And we know that because this time we have these parallel lines cut by this transversal here. It means that alternate interior angles are congruent. So it's the same reason. Alternate interior angles are congruent. Alright, and the last one, the green angles. Angle SPT is congruent to angle ORT, and we know that these are congruent because they are vertical angles. And we know that all vertical angles are congruent. Okay, so we have three sides congruent, we have three angles congruent, therefore triangle PTS is congruent to RTO. Right, so that's it for side one. So now let's flip over to page 2. Okay, page 2. We have two theorems that we're working with today. And our two theorems are the third angles theorem, and here the property of congruent triangles. Properties of congruent triangles. Okay, so here in this theorem, if two angles of one triangle are congruent, to two angles of another triangle, then the third angles are congruent. Okay, so in other words, if this angle here is congruent to this one, and this is congruent to this one, then we know that this angle here must be congruent to this one. So let's write that down. And I'm only going to use one letter for this one just to help make it clearer. If angle A is congruent to angle D, and angle B is congruent to angle E, then we know that angle C must be congruent to angle F. That's what this theorem is trying to tell us. If we know these two, then these third angles must be congruent. Okay, now we had properties in the previous chapter, the reflexive property, the symmetric property, and the transitive property. Those still apply to congruent angles. For any triangle ABC, if we're using the reflexive property, we know that triangle ABC is congruent to triangle ABC. The symmetric property, remember, that was the switching. So if I have triangle ABC congruent to triangle DEF, I switch those around and I say triangle DEF is congruent to triangle ABC. So symmetric is switching. Reflexive, that's seeing the same thing. It's like the mirror, reflection in the mirror. You're seeing the same person. Okay, the next one, this is the transitive property. If ABC is congruent to DEF, and triangle DEF is congruent to JKL, then I know that the first one is going to be congruent to the last one. So triangle ABC is going to be congruent to triangle JKL. Alright, here's a few more examples that you're going to see in your homework. Here's reading the diagram. In the diagram, we know that XYZ is going to be congruent to MNL. You can use color to highlight those, which ones are congruent. So here we're talking about the measure of XYZ. If you look at the name XYZ, you want the vertices to be in the same order. So here you would say the measure of angle, the X matches with the M, the Y matches with the N, and the Z matches with the L. So I didn't even look at the picture over here. I just looked straight at the congruent statement. Here, XY without segment notation and an equal sign is going to equal to, or I'm sorry, YX. So YX, it goes from the middle out to the left. So you have to go from the middle out to the left. So that's going to be NM. And yes, those letters have to be in that order. All right, this one here, LMN. L is at the end, then they go over to the front, and then to the middle. So here on this one, I have to do the same order. I have to do Z, then over here to X, then to Y. So this would be Z, X, Y. This one is YZ with segment notation. YZ are the two on the end. So this one has to be the two on the end. N, L with segment notation. And then here, LMN, LMN in that order. Oh, I'm sorry, here it says LNM. LNM going straight backwards here is going to be straight backwards here, so that's going to be triangle Z, Y, X. And this one right here, Y, X, Z, Y in the middle, over here to the left, and then back all the way around to the right is going to be congruent to starting in the middle, over here to the left, and then back around to the right. Notice how I use the name only to fill these in. I didn't even look at this picture. You are welcome to do that, or you are welcome to color this in to using the name and using color to match your sides. Okay, next one down here. Write a congruent statement. If you're able to prove that the figures are congruent, explain your reasoning. Okay, so here, if they're congruent, then all the angles are congruent and all the sides are congruent. Okay, so I have how many angles and how many sides? Well, first of all, let me check the sides. I've got one here, one here. I have two here and two here. And then my third side is the same. So XZ is going to be the same thing as ZX. So I can go ahead and put 3 hash marks here. Because I know using the reflexive property, it's going to be equal to itself. Okay, then check the angles. I've got this one congruent to this one. I have this one over here congruent to this one over here. And then finally I have this one here congruent to this one here. Now, since I have everything marked, all the angles and all the sides, I am able to write a congruent statement. So here I can say that triangle, and I'm just going to start this one with X, Y, Z. So triangle X, Y, Z is going to be congruent to triangle. And I started with the X, which is the yellow. So I have to start this one with the yellow. So that's going to be Z. Then Y is going to match the W, because Y is red, W is red. And then the last one is going to be the X. Okay, so blue and blue. Alright, so that's how you write a congruent statement. Over here, do I have enough information? I have this side congruent to this side, I have this side congruent to this side, and I have this angle congruent to this angle. Do I have a theorem that says that the third sides are congruent? If you look up here, I have the third angles, but not the third side. So here, I cannot prove that this side right here is congruent to this side right here. I cannot assume that. Also, I cannot assume that A, that's across from the yellow, and E, which is across from the yellow, these angles right here, I can't assume that those are congruent. So, in this one, I don't have enough information. So, I have to put not enough info. Okay, that's it for today's notes 4.2.